Hi, so in Chapter 8, we're going to discuss a different type of estimation for populations from a sample, and it's called confidence intervals. And it's exactly what you think it is. It is how confident we are that the population parameter lies within an interval of values. So if we just go ahead and kind of talk about what a confidence interval is, we can see here from the definition that a confidence interval is another type of estimate. Instead of being just one number, it is an interval of numbers, and it provides a range of reasonable values in which we expect the population parameter to fall. There is no guarantee that a given confidence interval does capture the parameter, but there is a predictable probability of success. So that means that if the probability of success is good enough, then we can say, well, if the probability that the population parameter can be in this interval, then we can be that much confident. So if our probability of success was 90%, then we would say, well, we are 90% confident that the population parameter falls within these reasonable range of reasonable values. So when we talk about a confidence interval, we talk about exactly that. We have to have a lower bound, and then we have to have a upper bound. So to have the upper bound and lower bound, we have to do some sort of calculation, and that involves statistics in our calculator. So if we have this point estimate, our point estimates in this class will just be the mean, sample mean, and then sample proportion. And then we have what we call this margin of error. Okay. So if we talk about standard deviation like we have in the past, like we always said, like, oh, the average is blah, and give or take, whatever that standard deviation. This is similar, except now we're not talking about mean and standard deviation. We're talking about a population mean that lies within this margin of error. Not really a standard deviation, but an error. Like it can be somewhere in here, right? Just because that probability of success is high enough. Okay, so the first thing we'll need is a point estimate, right? Like either the mean or standard population proportion. And a confidence interval for an unknown parameter consists an interval in numbers based on the point estimate. Now we need to talk about this probability of success, right? How confident are we? And that's called something, that's called the level of confidence, right? That's the level that we're confident that the population parameter will fall within these reasonable values. So the level of confidence is the expected proportion of intervals that will contain the parameter if a large number of different samples is obtained. So because we're discussing a distribution, a sampling distribution, that we're talking about not just a one little sample, but this is a confidence interval in which if I took many samples, that population parameter will lie somewhere in that range, and we're that confident, whatever that probability of success is. So here's a sample, here's a sample. So no matter how many samples I take, the population parameter, so here's mu, and we're using all of these x bars, and we say, hey, you know what? The probability of success is so high that you can expect the population mean to be between this lower bound value and this upper bound value. And so in that distance from the population mean to the lower bound, or the distance from the population mean to the upper bound, is called the margin of error. And I like to call it MO sometimes, because MO sounds so much cooler than margin of error. But anyway, so the level of confidence is given to us in the problem, and we can denote it as 1 minus alpha times 100%. So this piece is going to be reminding us of this alpha that we just discussed in the previous chapter. But we'll talk about this a little later. So I don't want you to worry about this little expression. I just want you to kind of think right now is just conceptualizing what confidence interval means and how we calculate it. And it's a really simple calculation, right? It's just like we just need a point estimate, which is usually given to us, and then we're going to add and subtract a margin of error. So again, I just want to reiterate that the confidence interval is a interval in which the population parameter could lie within a certain lower bound and upper bound. And we interpret this as the probability of success is good enough where we can be that confident that the population parameter will fall in those range of values. No matter how many samples we take in the population, that sampling distribution, we can be confident that there's this margin of error that the population parameter will lie. Okay, so let's just go to a simple example. It says a marketing department of an entertainment company is interested in the mean number of songs a consumer downloads per month from iTunes. Even though the population mean mu is unknown, we know that the population standard deviation is 1 for a sample size of 100. So we know that the standard deviation, the population standard deviation is 1, and then the sample size is 100. So what is the standard deviation for the sample mean? Well, recall that because it's a sampling distribution, we have to find the standard deviation with respect to the distribution. In this case, will be the sample mean. So this little symbol goes with the point estimate. Well, that's just going to be, recall, the population standard deviation over the square root of n. And so that's just going to be 1 over the square root of 100, which is, and then let me go ahead and here, 1 over 10. Or we could say that the standard deviation for the sample mean is 1/10 or 0.1. It's just whichever. Okay. So what this tells us is that we're not really going to have a population parameter because we're estimating the population parameter, right? And remember we said, oh yeah, we're looking for this MOS that will give us this lower bound and upper bound. So recall that even though we have a population parameter, really we don't really know much about the mean or a population proportion because we're estimating. So we're always going to be using the sampling distribution format. Okay, so then what if we take this example and go one step further and say the sample produced a sample mean of x bar equal to 2. So remember that we had the standard deviation of the sample mean to be 0.1, and now we know that the sample mean is 2, and it was out of a sample of 100. And remember the population standard deviation was 1. So if we want to find the 95% confidence interval for the population mean and interpret it in context of downloaded songs from iTunes, then we can think about the empirical rule. So the empirical rule, remember, for 95% said that if we're 95% of our data lies within how many standard deviations? 2 standard deviations, right? So that means that we could say that, let me do a draw line. This means that here's the population mean. And again, we don't have the population mean. We only have a sample mean, right? We saw that it was 2. So this means that you have this margin of error on each side, right? And this is a lower bound, and here's the upper bound. Well, because we're taking so many samples, we're saying that if 95% lies within 2 standard deviations, then we can say X bar is 2 standard deviations away. So I can take the sample mean and add and subtract 2 standard deviations away because I'm looking specifically at 95%, right? And then I would say, well, that means that I am 95% confident that the population mean will lie within these range of values. So let's go ahead and calculate that first. So that means X bar, so the lower bound is X bar minus 2 times 2 standard deviations. And then the upper bound would be X bar plus 2 standard deviations. And notice we use the standard deviation with respect to the sample mean because we don't know, we don't want to use anything outside the sample, right? Well, this just means that we have 2 minus 2 times 0.1 and then 2 plus 2 times 0.1. So that'll give us, 1.8, and then this one would be 2.2. So this means that the population mean will lie within 1.8 and 2.2. So, okay, so then we can say the 95% confidence interval is, well, we put parentheses, the lower bound, comma, upper bound. Okay, so that's like the first part of the problem. The second part states that it wants you to interpret. So let's go ahead and interpret. And this is kind of a blank interpretation. So we would say we are 95% confident that the population mean of, and then what are we talking about? We're talking about downloaded songs from iTunes. Are between 1.8 and 2.2 downloads. So let's reread this. So we are 95% confident that the population mean of downloaded songs from iTunes are between 1.8 and 2.2 downloads. And you can also say it more like casually in convert, like we are 95% confident that the average number, the actual average number of downloaded songs from iTunes are between 1.8 and 2.2. So just however you want to interpret, but it really, when you're doing a confidence interval, what you're going to start with in your interpretation always is we are this percent, whatever percent they give you, confident that the population and then mean or proportion is between these two values. So it's always like we are this confident that the population blah is between these values. Okay, so now I just want to kind of touch base with this alpha. Remember that we talked about how it was 1 minus alpha times 100%. That was like the level of confidence that I said we would talk about later. So it's a little later. Let's talk about it. So recall that the alpha in this case is area to the right. And so I can just put alpha here, right? Alpha is the area. And let me put it in blue. So there's alpha. And remember that this z-score that corresponds to this area in the right tail is Z sub alpha. So this alpha is the area in the right tail, and it's fairly small. And so if the area was like about 5%, I would subtract that from 1 and then multiply it by 100 to get the percent, and that would be the confidence percent. So in this next example, where let's say we have a level of confidence of 99%, what it's saying, if I drew this, that recall that here's the population parameter. Let's say, we'll just say it's mu or p, right? Population parameter. And if we're 99% confident that the population parameter lies within two values, then this is the middle 99%, right? Where the distance from the population parameter to the lower bound or to the upper bound is the margin of error, right? The MO. And so if I wanted to like kind of relate it to what we were doing prior, I would shade this, right? And this would be the middle 99% confidence, right? So what does this mean? This means that there's some area in the tail, right? If it's 99%, we know that there's 1% left over. But that's total. And if I split this in two tails, right, I know that this is going to be 0.5% in each tail. So this would be 0.5% and this would be 0.5%, right? And so that's what it looks like. So if we look at the area in the right tail, notice that it's going to be half, right? Or whatever is left over. So let me go ahead and write something. So now, if we have 1% left over, this implies that that's 0.01 and that's our equal to our alpha. So it's just whatever percentage is left over, right? And so the alpha over 2 in this case would be 0.01 over 2, which is equal to 0.005, which is the 0.5%, the half of the percent that we got here. So we will use this alpha a lot in the future, and then right now we're just looking at it in terms of what is left over. If they give us alpha, then I'll just subtract it from 100 and multiply it by, subtract it from 1 and then multiply it by 100 to get the confidence interval percentage. So this means that if alpha is given to be 0.01, then the confidence interval percentage is 1 minus 0.01 times 100%. And that in fact is 1 minus 0.01 is 0.99 times 100 gives us 99%. So if they give you the alpha, just so you know, the alpha is just the leftover percent, and then subtract it from 1 and multiply it by 100, it gives you the confidence interval. And usually they give you the confidence interval percentage. They rarely will give you the alpha, but sometimes they just talk about the level of confidence because it has to be how confident we are. And so, let me just move this up a little more. Okay, so now let's think about what this means. What does a 99% confidence interval mean to our sampling distribution and to what we really want to talk about when it comes to the population parameter? So we could say a 99% confidence interval implies that if 100 different samples that if 100 different confidence intervals are constructed or calculated, then we expect (99) of the intervals to include the population parameter and one interval will not. So this just saying is 99% confidence means that if I took 100 confidence intervals, we expect 99 of them to contain that population parameter and one of them not. So the higher the confidence, the more confident you are that you're going to have that population parameter within those range of values. So if you did a 95%, right, confidence interval, that means 95 will have mu or p, right, the confidence, the population parameter, and 5 will not. So if you did an 80% confidence interval, that means only 80 will have that population parameter and 20 will not. So that's the confidence that we have, right? It's just how confident we are, how many intervals out of 100 would have that population parameter. So we do like them pretty high, and that's why the alpha is such a little percentage of the tail, right? Because the tail is really small because we want this confidence interval to really contain this population parameter.